Hi everybody, I'm back. Hope you're having a good day. And I just want to review with you again the law of sines. We'll do a nice review and then we'll go on to the law of cosines. And I just want to add a little something into the mix. The law of sines and the law of cosines have specific times when they will be used. The law of sines will be used when we have some triangular congruency relationships. For example, if you can look and see that you have two angles and an included side going on, or when you have two angles and a non-included side going on in the given information, then we use the law of sines. So let's do an example of that. We have an angle here that's 39 degrees and an angle here that's 88 degrees. And, we could always find this third angle if we wanted to by adding these two together and subtracting from 180 to find out what this one is. But right now I'm not going to need that information because I'm going to be told something about the side opposite to 39. And now look, you have a non-included side going on. Angle, angle, non-included side. That satisfies this congruency. And the one they want to know is this. So I'm going to go ahead and use the law of sines to find out what that actual length is. And so it's going to be the sine of a 39-degree angle over the length of the side that is opposite it, and that's going to equal the sine of the 88-degree angle divided by the length of the side opposite it. And that's our unknown. We can only have one out of the four relationships that are unknown. Now we do our cross multiplication, and so we're left with sine 39 times x equals sine 88 times 22. Divide by sine 39. And do the same to the other side to keep it balanced. Now it's calculated time. What does x equal? X is going to equal 88 sine times 22 equals divided by 39 sine equals again, and you get 34.9. So x is really 34.9, and that is a rounded answer to the nearest 10. So this side measures 34.9 rounded. What if I wanted to then find this side? How could I do that? So I'm going to change the color so you can see what we're doing here. We'll call this side y. Well, now I do need to know how long this angle is. So 88 plus 39 is how much? 127. Right? Let's check our calculators. 88 plus 39, 127. And 180 minus 127 equals, check your calculators, 53. And so now I know how many degrees are in this angle, 53 degrees. And so now I can set up a whole nother set of relationships. I'm going to use the 39 and the 22 again. Don't use the 34.9, because what if you made a mistake there? At least you might get partial credit. So let's try this now. It's going to be sine of a 39-degree angle over 22 equals sine now of a 53-degree angle divided by y. And so now I have my setup, and I can just do exactly like what I did here. So it's sine 39 times y equals sine 53, I almost made another 5, times 22. Let's see if I can move this. Oh yeah, good, there it went. Okay, and now I'm going to continue to do my work. And so I want to divide by sine 39. Oh, should have left it alone. Change it back to red. Divide by sine 39. Divide by sine 39. And now I have y all by itself. Y is approximately, and now it's all calculator work, 53 sine times 22 divided by 39 sine equals. And so the length of that side is 27.9. And that's if you have to use it twice, which is possible. There may be problems like that. Okay. So if you have any questions, you're going to try and watch this video again. You're going to watch the videos that I have on the Canvas page again. Try and work them out step by step by pausing the videos and working them out before I get to it or the other video person gets to it. And then do some practice problems. Otherwise, you'll contact me during office hours and let me know of your concerns. Now let's go to the next page, which is law of cosines. So I'm going to open up a new page. Here we go. And we'll pick a nice new color, and we'll call this law of cosines. And this is when we use the cosine key. But meanwhile, when do we use this kind of intervention? Again, only with acute or obtuse triangles. Acute or obtuse triangles. And when we know the following relationships. When you know two sides and the included angles, so that would be SAS, or when you know all three sides and you want to find an angle. That's when you can use the law of cosines. And the formula goes like this. C squared equals A squared plus B squared minus 2A times B, and then times cosine, so it's going to go right next to it like that, cosine of angle C. I know it's lengthy, but it sort of looks like Pythagorean theorem quite a bit, and it might make it easy to memorize that way. C squared equals A squared plus B squared, so there's your right triangle. But then you have to undo the rightness by subtracting 2 times whatever side A measures times whatever side B measures times the cosine of whatever angle C measures. So let's do a problem. And again, there are many videos on this. I'm going to get myself a diagram of a triangle. There we go. Again, it is obtuse or acute. In this case, it's acute. And I'm going to fill in the information that we're given and show you the difference between what it looks like to have this information versus what it looks like when you're using the law of sines. So we're going to know two sides here, and we're going to know the angle in between them. And I'm going to ask you to find the length of side here. Let's see, right here. I want to know that side. So because I know this angle, I'm going to call this angle angle C. Now I'm pretty much aware of how to fill everything in this formula. Whichever angle you know, or whichever angle you want to know, that's what you call angle C. And now I'm just going to go ahead and figure out what that side measures. So it's going to be side squared. This is also known as your C, because that's the side opposite the angle called C. And that is all referred to as sides right here in the beginning part of the law of cosines. So it's going to be x squared. I don't know how large that side is. Equals, and doesn't matter, A or B. So 16 squared plus 18 squared minus 2 times 16 times 18 times the cosine of a 21-degree angle. Now we have everything filled in. Now it's calculator work. X squared equals, what is 16 squared? Oh, gee, if I had memorized it, I would know really quick. 256 plus 18 squared, everybody? Okay, 324. You're so right on top of this. And then this one, we need our calculators for sure. 16 times 18 times 2. That's 576. 576 times the cosine of a 21-degree angle. Now you might start saying to yourself, okay, order of operations here. What am I going to do first? Okay, and so let's do it in the order of operations. These two are going to go together, and so that's going to equal 580, and then it's still going to be minus, but these two go together. 576 times the cosine of 21, and you get approximately 537.7423. Going to the fourth place is perfectly fine. You're precise enough. And so you're left with x squared equals 42.2577. And then to get x squared alone, we just want x, so you're going to square root, and you're going to do the same thing here. Square root, and you get x is approximately 6.5. And that's how large this side is right here, approximately 6.5 units. And that's all there is to using the law of cosines. It's a lot of plugging in based on these values and going ahead and using your calculator and remembering order of operations. My next video will be about using the law of cosines to find a missing angle. Okay, see you soon. Bye.